we're going to unpack the fascinating economics behind a huge shift in modern defense, and specifically look at why a completely new type of weapon costs just $5 a shot.
So think about this. What if the future of warfare isn't missiles at all, but light? The US Navy recently tested a weapon capable of shooting drones right out of the sky using nothing but a focused beam of energy. No big explosions, no smoke trails, just absolute silence. But to really understand why militaries are rushing toward lasers, we have to look at the massive mathematical problem defining modern drone warfare. To get it, we have to contrast this staggering price of defending airspace against a wave of cheap incoming drones. There's this huge growing disparity between the cost of defense and the cost of attack. Modern conflict has inadvertently created this wildly unbalanced ledger. It's basically a giant, heavily skewed math problem.
Let's look at the numbers. Right now, the heavy lifters of air defense rely on interceptor missiles from incredibly sophisticated systems like Patriot or THAAD. And yeah, these are absolute engineering marvels. They can track and destroy threats from 60 to 100 miles away. But they come with a crushing price tag. We're talking anywhere from $1 million to over $4 million, just for one shot. Now hold that massive number in your head and compare that multi-million-dollar interceptor to the actual threat it's designed to destroy. You're often looking at a basic drone, like the ones we see being launched right now across regions by actors like Iran, that might only cost about $30,000 to build. These things don't even need to be highly advanced to be dangerous. They literally just need to fly in the right direction. It's kind of like totaling a hypercar just to stop a scooter. Which brings us to a really terrifying core dilemma. If every single interception costs exponentially more than the attack itself, well, who's really winning? When you are constantly losing money on every successful interception, you quickly realize this war isn't just about superior technology anymore. It's about economics. An enemy can simply bleed a defense budget dry by sending cheap drones. And that brings us to the $5 laser shot. The US Navy has been testing this absolute game changer to flip the financial equation on its head. It's called Locust. It's a directed energy weapon designed specifically to counter drones. So instead of firing a heavily engineered physical missile, it focuses a high-energy laser right onto the incoming threat. It completely trades explosives for pinpoint heat and precision. Here is the kicker, though. The crucial shift is relying on electricity instead of ammunition. The cost drops to under $5 a shot because you aren't manufacturing, transporting, and firing physical warheads packed with rocket fuel and expensive sensors. You're literally just paying the power bill. You just pull electricity from a generator, focus it through the laser, and fire. In practice, the engagement process is brutally simple. The system focuses a 20 to 35 kilowatt laser onto a tiny point on the drone. It just holds that beam steady, rapidly heating the surface until something vital, like a battery, a rotor, or a fuel line, experiences a critical failure. Once that component melts, gravity does the rest, and the drone just drops right out of the sky. Beyond just being incredibly cheap, this creates what militaries refer to as an unlimited magazine because it only needs electricity. As long as the system has a power source running, it can fire continuously. No reloads required, you never run out of ammo in the traditional sense, and this is exactly why there is massive investment pouring into this space right now. But of course, we have to talk about the limitations of light. While a $5 endless lasers sounds like a miracle weapon, actually, scratch that. It has some very strict physical limits. The beam doesn't just obliterate a target instantly. It has to physically hold on the drone for several seconds to transfer enough heat. That means dealing with targets sequentially, one at a time. Plus, the range is just a few miles, and heavy rain or fog diffuses the light. So if an enemy sends a massive swarm of, say, 100 drones on a cloudy day, this system absolutely cannot handle it alone. So what are the alternatives to laser defense? Because lasers have these blind spots, militaries are kind of scrambling for cost-effective options across the entire battle space. At the top, you've got advanced fighter jets flying hundreds of miles to intercept threats early, but firing a single Sidewinder missile costs up to $1 million. And that's not even counting the crazy hourly flight cost of the jet. Down at the bottom, you have cram cannons, which are basically high-speed turrets firing thousands of rounds a minute. Cheaper, sure, but they only work at the very last second. And right in the middle, we're seeing these new interceptor drones, literally launching cheap drones to ram into the enemy's cheap drones to try and match cost with cost. Another fascinating cost-effective layer is electronic warfare, or EW. Instead of destroying the drone physically, EW systems just disrupt its brain. They jam the signals, block the GPS, the whole 9 yards. And like lasers, this is highly cost-effective because there's no physical ammunition. But modern drones are adapting fast. A lot of them are now pre-programmed to fly blindly to a specific coordinate without needing GPS or live remote control at all, which completely renders this kind of jamming useless. Which brings us to the terrifying probability of air defense. Even if defenders throw all these expensive rockets, fighter jets, and jammers at a massive incoming drone wave and manage to stop, say, 80% of them, that 20% slipping through, that can still cause absolutely catastrophic damage to infrastructure or human life. It literally only takes a few making it past the net. And this is exactly why the future is all about layer defense. You see, this highlights why no single weapon, not even our fancy $5 laser, is meant to replace everything else. The laser's true purpose is to act as an incredibly efficient bottom net. It's a cheaper, highly sustainable layer designed to just soak up those constant, low-cost harassment threats. By picking off the cheap drones with light beams, militaries can finally save those million-dollar Patriot missiles for the truly dangerous, high-speed targets that actually demand them. And we are seeing this play out right now. Because a system like Locust is so compact and scalable, it's already being mounted onto military vehicles to protect troops on the move. It's being deployed to guard fixed assets like airports and military bases, and, as the Navy test showed us, it fits perfectly on ships. It gives you a vital, persistent layer of protection right where it's needed most. So, wrapping up this explainer, I want to leave you with a kind of chilling thought to chew on. We know lasers brilliantly solve the economic problem of a single, cheap drone. But as the economics of warfare continue to evolve, and adversaries realize they can launch swarms of hundreds or even thousands of $30,000 drones all at once, will even this perfectly layered defense be enough to stop them? Definitely something to keep in mind as we watch this technology race into the future.